we happen after a long time. Anyway, today's introduction to imaginary numbers and then defining a complex number with a little bit mentioning of its practical applications. After that, we shall understand algebraic identities and the complex number properties. We shall make an important summary to solve the chapter problems, and you will get it in the description link. Okay, so let us start. So far we know that imaginary numbers no use, but here it is very important. And you see one example, and it can be expressed as 4 into root over minus 1. Now the scientists have developed one idea for expressing this one. Root minus 1 is replaced by the symbol I, which is not read as I but iota. This iota will be used in the definition of a complex number. A complex number is nothing but an additive mixture of a real number and an imaginary number. So mathematically, to express in the standard form, z is equal to a plus iota b. A is the real part of this complex number and b is the imaginary part, and they are denoted as one more concept that two complex numbers z1 is equal to a plus iota b and z2 is equal to c plus iota d will be equal if and only if their corresponding real parts are equal. That means a is equal to c and b is equal to d. Okay, we come back to imaginary number powers again, okay, to understand something. If iota is equal to under root minus 1, then you see iota square is equal to iota into iota minus 1. Then iota cube is equal to iota square into iota. Already we have got iota square is equal to minus 1. Remaining iota, we should keep it as iota. Okay, so we can write minus iota. Okay, then come to iota to the power 4. We can write iota square whole to the power square. Here iota square already we have got minus 1 and then square equal to 1. Again iota to the power 5 is equal to, I can write iota to the power 4 into iota equal to iota to the power 4 is equal to 1, and this remaining iota is iota into 1 is equal to iota. Iota to the power minus 1 equal to 1 by iota is equal to, we can write 1 by iota into iota and here iota equal to iota by minus 1, because iota square is equal to minus 1 minus iota and so on. Now we are coming to understand the concept of the algebra of complex numbers. In lower classes, even in class 7, 8, we have got that a rational number into or subtraction addition of another rational number gives a rational number again. So it is satisfied under closure property. Here also for complex numbers, z is equal to a plus minus iota b. We shall see that if one number is added to another or multiplied by another one, z1, z2, etc., ultimately we shall get third number z3. That is also a complex number. That's why closure law satisfied. And then commutative law. Okay, for addition means z1 plus z2 equal to, somebody can write z2 first, z2 plus z1. In multiplication also, z1 into z2 equal to z2 into z1. Okay, by reversing no problem. And division also, subtraction also. So we understand like that: closure law, commutative law, distributive law, associative law. Okay. And then remaining additive identity and additive inverse of a complex number, and multiplicative identity and multiplicative inverse of a complex number. Now see, additive identity of a complex number is 0 plus iota 0. Okay, this is the identity, and ultimately see that it is 0 plus iota into 0 equal to again 0. Okay, and additive inverse of any complex number, suppose z is a complex number, then additive inverse is minus z, so that z plus of minus z is equal to 0. Okay, now see, multiplicative identity is 1 plus iota 0. Actually it is 1. Okay, so it is denoted by 1. And multiplicative inverse of a complex number z is such that the multiplication of these two numbers will give the identity. Okay, if z is a number, then multiplicative inverse is given by z to the power minus 1. Okay, now let us see by multiplying the two things. Z into z to the power minus 1 equal to z into 1 upon z equal to remaining 1. Okay, after that we are going to see some identities. Complex number identities are same as the algebraic identities in lower classes. Say class 8, 9 we have learned a plus minus b whole square is equal to a square plus minus 2ab plus b square we have got, and a square minus b square equal to a plus b into a minus b we have got. So here, see, if z1 and z2 are complex numbers, then z1 plus z2 whole square, z1 minus z2 whole square, z1 square minus z2 square, it will be in that form only. Okay, to save time I am not going to show you in details. Okay, so we have seen that no difference in that in identities and as well as for algebra of complex numbers. Now let us solve one problem based on the equality of complex numbers. Okay, for example, you see the question, if 4x plus iota into 3x minus y equal to 3 plus iota into minus 6, then find the values of x and y. Comparing the real part, which 4x should be equal to 3. So 4x equal to 3 implies x is equal to 3 by 4. Again, imaginary part of the first number must be equal to the imaginary number of the second part. So 3x minus y is equal to minus 6. Okay, now here x has been got 3 by 4. So 3 into 3 by 4 minus y equal to minus 6. See, minus y equal to this, minus y equal to minus 33 by implies y is equal to plus 33 by 4. Okay, so solutions are x is equal to 3 by 4 and y is equal to 33 by 4. Okay, so next day we shall start from the exercise.